Okay, now we have the length. Okay, a 20 cm long metal rod CD. Okay, so this is the length. Okay, L. Sorry. So this is the length. Um, 20 cm long metal rod CD is moved at the speed of 25 meter per second. Okay, so this is the speed V across a uniform magnetic field of flux density 250 millitesla. Okay, so this one will be the magnetic field strength. Okay, this is the B. Okay, magnetic field strength. The motion of the rod is perpendicular to the magnetic field as shown in the figure. Oh, so he says that the motion is perpendicular to the field, to the magnetic field. That means this is he says that the velocity is perpendicular to the field. Okay, this denotes that the angle theta is 90 degree. Okay, angle theta is angle between V and B. Okay, is 90 degree. Okay, as you can see here, the velocity and magnetic field exactly 90 degree. Now, calculate the motional induced EMF in the rod. So, what's the EMF induced in the rod? So he asked for E induced. Okay. And then the next thing he asks, B, he asks, the rod is connected in series with a resistor of resistance 15 ohm. Okay. So there is a resistor added there. Resistance equal to 15 ohm. So something like this, yeah. So this, what he says here is this rod is connected to a resistor. So something like this. Yeah, something like this, yeah. The rod is connected in series with a resistor 15 ohm. Okay. So you must label A, B, C, D, yeah. Label it so easily you can determine the direction of the induced current. Okay. Now, determine the induced current. So he asked for induced current and the direction. So induced current is the I induced. Okay. And then he asked for the total charge. Sorry. He asked for the total charge passing through the resistor in 2 minutes. So he asked for the total charge Q when the time equal to 2 minutes. Okay, so this is the question. Okay, so the information. This is a questions about the induced EMF for a moving conductor. Okay. So, information given is the length, velocity, magnetic field, and the angle theta. Yeah? So, remember, you must change all the SI unit, centimeter to meter. Okay. The Tesla change to Tesla. Okay. All the SI unit need to convert. Yeah. Convert to SI unit. Okay. Okay, and then he said velocity perpendicular to magnetic field. This means that the angle theta is 90. Yeah, theta is the angle between velocity and magnetic field. Okay, so this angle theta, where is it? Yeah, we will see. So the first question asks for the induced EMF for the straight conductor. So it is the. So what is it? Okay. So the formula for the induced EMF for a moving conductor is L multiply V cross B. Okay, L multiply V cross B, or we can say it is a BLV sine theta. Okay, we use sine theta. We use sine theta because it is a cross product. Okay, and since this cross is between V and B, that's why the angle theta is angle between V and B. Okay, because it's cross between V and B. Cross between V and B. So the angle theta is between V and B. And it is both V and B is perpendicular. That's why it is 90 degree. Okay. So this is we can say BLV sine 90. And we know that, of course, we know that sine 90 always equal to 1. Okay, sine 90 equal to 1. So we can substitute all the other values. Magnetic field is 0.25, length is 0.2, velocity 25, and sine 90 equal to 1. And then, so finally we'll get 1.25 volt. This is the induced EMF in the straight conductor. Next, he asked to find the induced current for a straight conductor, and also the direction of the current if it is connected to a resistor. Okay, so how to find the induced current? Very easy. We already got the induced EMF. So to find the induced current, we just use the formula E induced equal to I induced R. E equal to IR. Okay, E equal to IR. So 1.25 equal to I induced. Resistance is 15 ohm, and so I induced will be equal to 1/12 ampere. Okay, that's our current. And where's the direction of the current, induced current? Okay, that one you need to use the right hand rule. Okay, this is what we call the right hand rule. Okay, so all this while we just use right hand, we never use left hand. Okay, right hand rule, the thumb is the induced EMF or the current. The finger, the forefinger is the velocity, and the palm is the magnetic field, magnetic field strength. Okay, so use our hand. Okay, now you see the velocity to the left, magnetic field going out of the page. So where is the induced current? Okay, so use our hand. So our forefinger to the left, velocity, and then our palm showing out of the page. Out of the this palm is out of the page because the magnetic field is out of the page. Okay, when the magnetic field is out of the page, so out of the page, velocity to the left, magnetic field out of the page. So our thumb is going upward. Our thumb is going upward. So our thumb is the current. Our thumb is the current. Current. So current, induced current is going up. So we got our direction of induced current. Direction of induced current is going up. So it will flow out from here. The induced current will flow out from here. Will go down through the resistor here, and then we'll go back to the conductor this way. Okay, so we can say if at the conductor the direction is upward. Okay, upward, or we can say is from D to C. Okay, if direction of the conductor D to C. If through the resistor it is downward. It is downward. Yeah, or we can say A to B. Direction of the induced current is A to B. Or if through the conductor is upward, D to C. Okay, so we can say induced current is from D to C. That's the answer, yeah? Or you can say upward. So it's just like this conductor now has become like a temporary battery, yeah? Just like the current coming out from C. So C become like a positive terminal, and current entering D like becoming a negative terminal. Okay, it's just like becoming a CD has become like a battery, like this. Okay. So this is the resistor, positive terminal, this is the C, and this is the D, negative. This is become like a, so this is our induced EMF. Our induced EMF, there is current, induced current in the circuit. Okay. So induced EMF produced in the conductor and got induced current coming out from the induced EMF. Okay. So the direction of the induced current is D to C. Okay, upward, D to C, like this. And then question 2, he asks if the time taken is 2 minutes, how much charge has passed through the conductor, yeah, for this induced current. So first of all, we must so very easy to find the charge is we just use formula Q equal to IT. Okay, Q equal to IT. So Q equal to I, we already got the induced current 1/12, and then time taken is 2 minutes. 2 minutes you must convert to second. 2 times 60 seconds. So finally you will get the total charge 10 coulomb. This is the amount of charge passed through the conductor. Okay, so that's it for this question.